Elephants are truly magnificent creatures. They have huge brains, long memories, and huge tusks. They use their tusks for digging for water, stripping bark off trees, and, of course, for fighting. But they don't just fight each other. Sometimes they also fight other animals like hyenas, lions, and, yes, also dinosaurs. You heard that right, dinosaurs. Dinosaurs that were around during the age of the dinosaurs 65 million years ago had to deal with elephants. Welcome to Paleontology. Today we will look at how elephants shaped the world during the age of the dinosaurs. To understand what elephants did during the Cretaceous, we need to talk about how elephants work today. Elephants are ecosystem engineers. That means that they shape the environment around them through their activities. For example, elephants will dig for water in dry seasons. They strip bark off trees when they are hungry or bored. Of course, they eat plants. All these things change the landscape around them. Let's take the watering hole they dug. When it is dry season and there is no water to be found, elephants use their tusks and their feet to dig for water. This creates a watering hole where they can drink from, and other animals can also benefit from this. It can also help plants grow, because now the soil around here has access to water. So instead of being a desert, it might become grassland. There are also other animals that are dependent on elephants to make these holes, because they cannot dig as well as an elephant can. And if elephants did not do it, then those animals would have to wander further in search of water. Then there is the bark they strip off the trees. Bark beetles often live under the bark of trees. They tunnel through the wood and eat the soft inner bark. Sometimes these tunnels kill the tree, other times the tree survives. Either way, the bark beetles benefit from the elephants. And since bark beetles lay their eggs in dead wood, this also benefits the beetles. These beetles also serve other animals, like ants, because ants will sometimes move into the dead branches. The point is that the ants get access to food thanks to the elephants. So there are many species that indirectly benefit from the elephants. And then there is the food they eat. Of course, plants are on the menu, but not all plants are created equal. Some plants are more nutritious than others, and elephants know which ones they prefer. This means that less nutritious plants can take over because the elephants will eat the good stuff first. This could lead to certain areas being dominated by certain plants because the elephants only eat the ones that they really have to. And since elephants eat so much, they can really affect a landscape in a relatively short amount of time. This means that the plants near water sources will look different from the plants far away from water sources. The same goes for places where there are elephants and places where there aren't any elephants. Places where there are elephants will look different from places without elephants, and this effect can be seen in the fossil record. In the genus of Parasaurolophus, for instance, there are two species, Parasaurolophus walkeri and Parasaurolophus tubicinodens. Parasaurolophus was a herbivorous dinosaur that lived in what is today North America. Both species look pretty much the same, but P. tubicinodens is larger. This shows that there was a change in body size within the genus. Now, body size changes can be caused by several things. One of them is diet. If the food is good and plentiful, then individuals can grow bigger. If the food is scarce, they will be smaller. Now, when studying these fossils, scientists discovered something weird. The older individuals were smaller than the younger ones. This doesn't make sense. Usually, if an animal is getting bigger throughout its life, then it gets older and bigger, not older and smaller. So what happened here? Well, it turns out that the adults got so big because there was a lot of food. But then some environmental change occurred, and the growth of new vegetation slowed down. The new plants were not as nutritious as the old ones, and this meant that the adults had to shrink. Couldn't get enough food if they stayed that big. It seems that this happened in several other species of dinosaurs as well. They were all around the same size. Then suddenly, in the latest Cretaceous, they started shrinking. It looks like the food became worse, and the dinosaurs had to adapt. But where did the food come from? What made the food suddenly worse? Well, the answer to that question lies in Africa. A team of paleontologists was excavating a site when they discovered the site was full of fossils. Literally hundreds of thousands of fossils of vertebrates. They were in a place called the Tendagru Formation. This formation is famous for having a ton of fossils from the late Cretaceous. Most of the animals there were medium-sized, but then they found a few larger animals. These included 2 adult sauropods, a young Titanosaur, and a young sea Megalodon. When they analyzed the sediment where they found these fossils, they discovered that it was mostly made up of mud that comes from rocks that are rich in iron and aluminum. This means that it was deposited in an area where it was raining a lot. But this does not explain why there were so many fossils there. There must have been a disaster of some kind. So they studied the geology of the area, and they found out that the mud was actually deposited in a lake that was created when a big river changed its course and cut off a section of the main river. This created a large lake with stagnant water. The water was stagnant because there was no way for it to leave. It was trapped. This meant that the water quickly became anoxic. Anoxic meaning that there was no oxygen left in the water, so no fish could live there anymore. Only bacteria could survive in such conditions. But if no animals could live in the lake, who left all those fossils behind? Well, the answer was right in front of them. When you have a bunch of medium-sized animals living in an ecosystem, it is likely that a predator will evolve that can eat them. In this case, it was C. Megalodon. C. Megalodon was a 13-meter-long carnivorous dinosaur. It was a theropod, which means it was closely related to the famous Tyrannosaurus rex. However, unlike T-Rex, which walked on 2 legs, C. Megalodon walked on 4 legs. It wasn't the only large carnivore in the area. There was also a relative of Ankylosaurus called Boreopelta markmicheli. It was also a relative of Smilodon called Hoplophonius jasumus. Finally, there was also a relative of Mammuthus called Titanoboa saragenensis. These 3 predators lived alongside each other. They all had to eat something, and that something was the medium-sized animals. But when the lake was created, everything changed. There was no more medium-sized prey. There was only one size, large. This meant that the small C. Megalodon had to get bigger or starve. The same was true for the other predators. They all had to grow or die. This is how they ended up as giants in this fossil layer. They needed to be big to hunt the giant prey. C. Megalodon was an apex predator. Its teeth were serrated like a shark's teeth to slice through flesh. It had a huge head and a huge brain. This made it smart and aggressive. It probably hunted in groups. After all, it wasn't the only large carnivore in the area. Hunting in groups would have been the best strategy to bring down the biggest prey. One of those prey animals was the sauropod. Sauropods were the biggest animals on the planet. They were the equivalent of elephants today. They were herbivores, used their tails to defend themselves against predators, also used their tails to help them balance. Imagine trying to walk with a 20-meter-long neck. It's not easy. These sauropods were Titanosaurs. Titanosaurs were a diverse group of sauropods. They lived almost everywhere during the late Cretaceous. They came in a variety of sizes. These Titanosaurs were around 18 meters long. Their skulls were very flat, almost pancake-like. This helped them reach up to the highest leaves on trees without having to raise their necks too much. They also had very large eyes. This may have helped them detect predators from afar. Now, while the sauropods were the largest animals in the ecosystem, they weren't the only ones. There was also another giant, a relative of mosasaurs called Tylosaurus. Mosasaurs were aquatic lizards. They were the apex predators of the oceans. They ate everything. They even ate each other. One mosasaur can actually be seen eating a crocodile in a famous scene. In the Museum of the Jura in Argo, Switzerland, this particular mosasaur is a tylosaur. Tylosaurs were huge. They reached lengths of 15 meters. They had teeth like swords to slice through flesh, and they were ambush predators. They would wait for a large animal to swim past, and then they would strike. These huge animals all lived in the same place. They all depended on each other to survive. The Titanosaurs ate the plants. The theropods ate the Titanosaurs, and the Tylosaur ate the theropods. The C. Megalodon sat at the top of the food chain. Nothing in the lake was big enough to eat it. But then the lake dried up. The river changed its course back to how it was before, and the ecosystem collapsed. C. Megalodon, B. Mark Mitchell, and Hoplophonius could not get enough food. The sauropod and Titanoboa did not depend on the lake. They could go elsewhere to find food. The ecosystem shifted again. The Titanosaurs went extinct, and the C. Megalodon grew smaller again. The Hoplophonius disappeared altogether, and Titanoboa became medium-sized once more. The Cynolophonus was too specialized. It could not change its diet. Titanoboa could survive on smaller prey. Hoplophonius could not. The lake had a devastating impact on the entire ecosystem. Everything changed after it dried up. The predators had to get bigger to catch the sauropods. When the lake dried up, the sauropods disappeared, and the predators had to get smaller again. In the end, all of this came full circle. The ecosystem was shaped by the sauropods. They were the engineers of the ecosystem. They changed the landscape by eating certain plants. They helped create the conditions for the lake by being prey for the predators. And when they disappeared, the predators had to disappear as well. And this is just one of many examples. Sauropods are found all over the world during the late Cretaceous. And wherever they are the ecosystem engineers. They are the elephants of the age of dinosaurs. That's it for today's episode. Thank you all for watching. Subscribe if you haven't already, and leave a comment down below with your ideas for future episodes. And as always, thank you for watching, and see you next time.